course on heat and mass transfer. Course instructor, I am Dr. M. Armstrong M.E, PhD, Assistant Professor, Department of Mechanical Engineering, PSN College of Engineering and Technology. So in this course, we are going to discuss different topics related to heat and mass transfer. In that, the Unit 1 covers the important concepts on the heat transfer, because the basic is the main role which plays a major part in each and every concepts. So the basic concepts will be covered in this particular Unit 1. Especially I am going to cover the Unit 1. I have separated the Unit 1 into different lessons. So you could see the lesson 1 starts with the heat transfer modes. So in that we are going to speak the two topics. The one is general introduction of heat transfer, and the second one is heat transfer general applications. In lesson 2 we are going to see the conduction equations. So in that I have split into 3 topics, because the conduction is very important concept. So in that we have split the concept into 3 topics. Topic 3 covers Fourier law of conduction. Topic 4 covers the one-dimensional heat conduction equation, and topic 5 will covers 3-dimensional heat conduction. In lesson 3 we are going to see the steady state heat conduction. So in steady state heat conduction we are going to see the topics on steady state heat conduction, composite wall and composite cylinder, critical thickness of insulation. And lesson 4 will covers the unsteady state heat conduction. In that we will cover 2 topics, the lumped heat transfer and usage of Heisler chart. In lesson 5 will go on for applications. So in that we could see the extended surfaces application and cooling of machines by extended surfaces. We will see some try to solve some problems related to these concepts also. So as I mentioned, we are going to the lesson 1, heat transfer modes. So first of all, we want to know, or we want to understand what is heat. So in generally we will say heat is a form of energy, so that can be transferred from one system to another system with the help of the temperature difference. So temperature difference here denotes, as always we know, the heat will flows from higher temperature to lower temperature. We can say similar examples for these kind of phenomena, like you can say the water always flows from higher heat to lower height. As we say the falls will fall from the mountains from higher height towards the lower regions. So this is a thing which always will do in nature. The similar way in nature, the important phenomena is called a heat. It's a form of energy that can be transferred from one system to another system. That is mainly from higher temperature to lower temperature. That is the thing we want to have in our mind. And it is an energy in transit. So it is the energy which can able to flow from higher level to lower level, as I already mentioned. So it's a transfer will happen from higher level to lower level. So as I mentioned, the transfer of energy as heat is always from higher temperature medium to the lower temperature, so until it reaches the equilibrium condition. The SI unit of heat is joule or joule per second, or watt with respect to the time as well as respect to the area. We can able to say, we can distinguish the factors, joule per second, watt per meter square, like that. But main unit, SI unit is joule. So I can able to show some pictures related to the heat transfer applications. A simple example we can say from the hot coffee cup, which I have taken from the heat and mass transfer book Eunice Gengel. So you can see here the hot coffee is of temperature 70 degrees Celsius, and the environment temperature is 20 degrees Celsius. As we know, the heat always flows from higher temperature to lower temperature. So in this case, we can able to see that the heat is flowing from the hot cup of coffee to the cold region, so that after a particular time we can able to see the hot coffee is reduced, having a reduced temperature, and we could see the coldness in the coffee, because the coffee temperature will be reduced till the coffee and the environmental temperature will have the equilibrium condition. That is, for example, the environmental temperature is 20 degrees Celsius, till the coffee reach nearer to 20 degrees Celsius, like you say 25 or 20. So till the coffee temperature will be, heat will be flows from coffee to the environment. So as I mentioned, the heat always flows from higher temperature to lower temperature until it reaches the equilibrium condition. So similar example or application we can able to see in different cases. In the human body, we can able to see the heat from the body to the environment, and in air conditioning system we can see the heat applications in electronic equipment, heating systems, in power plants, in different systems. Several applications all over throughout our earth is consist of heat, as we know, because the earth is rotating. So inside we are having a core or lava, so it's consist of heat. So without heat, no humans, or you can say the living things, can exist. That we want to understand what is the importance of heat or significance of heat. So we go to the second thing, like concept of heat energy. So heat is everywhere, as I mentioned, the heat is everywhere. It's available in living and non-living things, because we know every material is composed of atoms. So all the materials store internal heat energy. Example, we can say the sun and the lightning I have shown here, but we can say all the living things, and wherever the non-living things having all atoms, we can be able to see the heat is stored as internally. So one of the questions we will always have, what is the difference between heat and temperature, as well as the difference between heat transfer and thermodynamics. So as I mentioned already, heat is very important concept. So but we will learn thermodynamics. So thermodynamics as a concept. Before that, we will see what is heat and temperature. So heat and temperature, as I mentioned, heat is one of the energy in the universe, and it is available everywhere, and the heat always flows from hot to cold. There is no unit, as I mentioned, there is no unit of 1 heat or 2 heat or so on, but we mentioned in joules as well as in watt. And the heat can be measured with the help of another important unit named the temperature. So temperature plays a major role, because temperature here we do not how the heat is stored in a particular system. So the temperature is nothing but the hotness, measurement of the hotness and coolness of a body. So level of temperature can be determined with various thermometers we are having. We can able to measure the temperature with the help of those thermometers. So different type of thermocouples or thermometers are available to measure the temperature. It is measured in terms of degree centigrade, Fahrenheit and Kelvin. So as these are very simple concepts we have already studied in our lower studies. So we can able to see here, as I mentioned, what is temperature between the two systems. So if we say the hot and cold body, the temperature will always flows from hot body to cold body till it reaches the equilibrium. So this is the basic we know. Second thing is, we want to know why we are going for heat transfer. So already we know what is thermodynamics. So earlier we have learned what is thermodynamics in our lower degrees. So in that, why we are going for heat transfer? Because heat transfer in thermodynamics, we won't speak about the transfer of energy with respect to time, but in heat transfer we will mainly focus on the flow of energy with respect to time. So in these cases, we will always want to know what the concept behind the heat transfer is happening. Okay, so we move on to next. So we are having heat transfer methods. So as I mentioned earlier, that is high. It always flows from higher temperature to lower temperature, and it till reaches the equilibrium condition. So we are having different types of or different modes of heat will be transferring. So simply we can able to say the till it reaches equilibrium state, wherever, for example, high pressure air to low pressure air. So till it reaches equilibrium state, all the cases will be happening. A simple example I have mentioned here is blasting balloon with sound proves the state of reaching equilibrium rapidly with respect to pressure. With respect to heat transfer, we have mentioned high temperature, lower temperature till it reaches the equilibrium temperatures. So we know already we are having different types of heat transfer modes. Example, we are having conduction, convection and radiation. So inside a room I have shown you the three things are happening combinedly. For example, conduction is happening between the walls and convection is happening between the walls of the roofs towards the room inside the air, and thirdly the radiation is happening from the firewall to the atmosphere. So all these three things I have shown you in the example in the single room itself, but we will learn it detailedly in the upcoming slides. So as I mentioned, the mechanism of heat transfer or heat transfer modes of three different approaches. We are having three different modes of heat transfer. The first thing is conduction, and second thing is convection, and third thing is radiation. So you can see here the conduction is nothing but the heat transfer occurs or takes place in one single medium. For example, we can say only in solids the heat will be conducting between the molecules of the solids or the molecules of the liquids or the molecules of the gases. Anyway, each cases we call it as it is a conduction. So conduction will happening only in a single medium. So that we call it as a conduction. Example, hot metal. For example, if you take here, so one end we are heating, another end we are holding in our hand. For example, if you take, the heat will be transferred from the one end to another end quickly through the molecules or atoms which absorbs the heat, and it vibrate because of the energy it absorbs, and then the molecules will be transferred to the other molecules, and appropriately it will go into the end of the system quickly through the mode of conduction. So that we call it as the conduction process. That is, the energy will be transferring or heat will be transferring with between the atoms or the molecules inside the single medium, for example solids or liquids or gases. The second thing is convection. So we'll see detailing in single slides in the next phases, but I'll show you, I'll just give you a brief about these parts. So convection is nothing but the heat transfer takes place in two different medium. Okay, so two different medium, for example solid body to liquid or liquid to gases or gases to solid, whatever it may be, two different medium will be involved or due to density difference. So these things will happen, and this part we call it as a convection. So example, the hot metal cooled in water. So it's some of the example we can say, a hot metal cooled in water. And radiation. So radiation is nothing but this is a heat transfer which will be occurring without any medium. So in conduction only one medium, in convection we are having two mediums, and radiation without any medium the heat will be transferring. So for example, if you can say the sun, from the sun the heat will be transferred to the earth. So in between sun and the earth we don't have any space, that is we don't have any medium to transfer, but we are having only space. So there are no medium between the sun and the earth. So how it transferring? So because of the electromagnetic radiation from the sun to the earth, it reaching, so that type of heat transfer we call it as a radiation. So heat transfer from sun to earth. So next thing is, as I mentioned, we will see detail in single slides, like conduction. So conduction, as I mentioned, while on the one end of the rod, a metal rod, we are giving some heat. So in that the heat is transferring to the rod. So while transferring, we could able to see that many atoms will be present in the rod, and it is closely packed. That is very, very important. All the atoms are closely packed. So because of that, the first atom will absorb the heat, and after that it will transfer to the next atom quickly, and then to the next atom. So vice versa, it will move to the nearby atoms through vibration of the atom, because of the atoms of the heat energy, and it can't able to withstand its energy, so that due to the vibration or kinetic energy of the atom, it will transfer its energy to to the next atom, and the same will be happening to the next atom. Like that, it's move on, and it will reach wherever till the end of this atom. Okay, the rod. So we can able to feel the heat while the heat is reaching here. So this is called conduction. So we want to clearly identify what is happening in the conduction. The conduction we can able to see that the energy is transferring between the molecules. That is very important. Between the molecules, because of the kinetic energy, the energy will be transferring, and the mode of heat transfer will be called as a conduction. So next we will see the conduction is happening. So as I mentioned, the vibrations are happening in this particular case. So vibration of the molecules in a lattice and the energy transport of by free electrons which is present. So clearly I have given you the picture of what is happening here. So before that I will rub here. So you can able to see here. So as I mentioned, each molecules are closely packed. So because of the closely packed nature of the solids, the heat will be absorbed by the molecule and it transfers the energy to the nearby molecules. So because of that, heat travels along the rod, and we can able to see heat always flows from higher temperature to lower temperature, that is from hot to cold very quickly. Similarly, we can able to see the liquids having because the molecular collision, because in liquids and gases the molecules are not closely packed, there will be space between the molecules. Even though it is having space, because of the energy absorbed by a single molecule, due to its kinetic energy, it goes nearby to the molecule and it collide and to transfer its energy to the nearby molecule, and thereby the heat will be transferring throughout the medium. Likewise, here also the gas, the same similar kind of thing will be happening in the gas also. So these are very important concepts. Only I have given in a detailed fashion, so you would be able to understand very easily, and very simple terms I have given for your understanding. Okay. Next thing is we are going to see convection. So convection is nothing but, as I mentioned already, it will be happening between two mediums, either solid to liquid, either from solid to liquid, or from liquid to gases, or from gas to solid. So either way, the heat will be transferring from these two different mediums, that we call it as a convection. And here also the molecules will behave as the main part. As a simple example, I can able to say, take a vessel, and inside the vessel we are pouring water, and here we are heating the bottom of the flask or vessel. From that we can able to see that I have given the enlarged image of this. So here we can able to see this is a solid part of the particular flask. So here I am going to discuss two things. One is conduction, because here everyone we can able to see the heat is transferring to the particular base. So in this base, the completely it is a solid object, so the molecules will be transferring between this section, and it will reach throughout this section. Since it's a solid object, first of all the heat will be transferred throughout these molecules, and because it's only single medium, so this type of heat transfer we already know it is nothing but a conduction, so which we have seen in the previous slides. And next thing, these molecules after getting completely heat, the nearby these molecules will transfer its energy to the nearby molecules. So if we can able to see here, the nearby molecule is nothing but a cold water I have poured inside. So because of the heat, this heat travels from solid to liquid medium, or the liquid molecules, which denotes that there are the implication of two different mediums, that is, this is the liquid and this is solid. So with respect to that, we can able to say that the transfer of mode which is happening is nothing but convection. So convection nothing but the heat will be transferring between two different mediums. So the heat is transferring now from the solid part of flask towards the liquid which is poured inside it. So automatically this molecules will transfer its heat to the nearby molecules. It's nothing but a conduction which is happening inside, and this transfer will behave and it will make it as a conduction part, and throughout the conduction will be happening. And after that we can able to say this layer from liquid to gas, because the air molecules will be present, so cold air will be there, so this air will be get attracted towards this heat, and the heat will be transferred from higher temperature to lower temperature, as we know. So this heat will be transferred to the air towards the nearby section, and it creates the next term, convection, again from liquid to gas or air. So this is what the convection denotes. I hope you have understood what is convection is. So convection, I think, will be happening between two different mediums, that we want to make it sure, and due to density difference also this convection will be happening, because convection is of two types. One is natural convection. The convection occur in two types, so we'll learn it detail in next classes, but try to know the convection is happening in two different types. One is natural convection and another one is forced convection. So whatever the words or whatever the terms we are learning here, you should have in your mind whatever the terms we are learning. From that term or word itself, we can understand what it is saying. For example, here we can say it is a natural convection. So naturally the heat is going to convect. So that we call it as natural convection. Forced convection, we are going to force the heat through some external mediums. For example, you can say fan as an external medium, or any other blower. So like that, some external equipment we will use, and we will make the heat will be transferred from one medium to another medium. So that kind of heat transfer we call it as a forced convection. From the word itself, we can easily say what it defines. So I hope you have understood what is convection is. So next we are going to see another one mode of heat transfer. So as I have mentioned earlier, the next mode of heat transfer is radiation. So radiation is nothing but, already I have given an example. So from the sun the heat is traveling through electromagnetic radiations. So the heat is falling and it reaching the earth, and we people are observing some amount of heat. We are feeling the heat of the sun, even though sun is not nearby, it is far away from us, as well as there are no mediums in between the sun and the earth. So in between we can able to say some space, the space is there, and while passing inside we can able to see some clouds which are passed by, but without that also the direct radiation will be falling towards the earth. So this kind of heat we call it as the radiation. So without any medium, if the heat is traveling, so that process we call it as radiation. Okay. So I can able to see three things. One is conduction, second thing we have seen is convection, and third thing is radiation. So if I give some tabulation towards it, we will easily say that what it is. So conduction is happening between molecules. So all things will be happening between molecules, but only in single medium. That is very important. So only in single medium. So example, we have seen so many examples. So metal rod heating or cooling, anything. So these are some example. Second thing, we have seen convection. This is happening between two different mediums, as well as we know due to tensile difference. So it will be traveling between two mediums, solid to gas or solid to liquid. So in any cases we call it as a convection. So radiation, we know without any medium, if the heat is traveling or transferring, that we call it as a radiation. So I hope you have understood the three modes of heat transfer. Very important. If we know all these three transfer of modes, we can able to easily apply these concepts in the all applications which we are using in our everyday life. So industries mainly we can able to say power plants and solar, wherever the heat is available in all areas we will use these concepts for finding its performance. So this is a summary we have seen already. So we have seen three modes of heat transfer. So and we have seen the basic concepts of heat, what is heat and what is temperature and heat, and what is the difference between thermodynamics and heat transfer, and thereby we have seen different modes of heat transfer: conduction, convection, radiation. So this is a summary. I hope you have understood well about these concepts. So next class we will discuss the concepts related to conduction, where we can able to see the Fourier law of conduction, and with the help of this Fourier law we will solve some simple problems to make sure we could apply what we have learned in the previous sections. And before that, we want to see some terminologies related to this, like for example, you say thermal conductivity. These are some terminologies you want to know before going for solving the problems. So we will discuss these things: what is thermal conductivity and what is thermal diffusivity. So all these things we will go through, and we will solve a simple problem in the next class. Thank you so much.